Hello, Honors Geometry, and today we're going to be looking at the area of three different shapes. Where specifically quadrilateral is going to be the area of a trapezoid, a kite, and a rhombus. We're going to start off with a couple ways to find the area of a trapezoid and the relationships of different segments that are going to also allow us to find the area. So, one way to find the area of this trapezoid, well, we first need to start talking about the dimensions. The height will be the perpendicular distance between your two bases. So I'll call this base 1, and I'll call the other one base 2. It doesn't matter which one's which. You can flip-flop them, it doesn't matter. Now, one way to find the area of this trapezoid, which really means to find the number of square units or squares inside of this shape, which we can't simply just count, because you can see in certain areas it's not a full square, and you can't estimate that. Well, you could estimate that, but it's just not going to be accurate. So to find the exact area, I'm going to take this shape and I'm going to flip it. Okay, so meaning the base 2 is now going to be 3, 4, 5, 6, 7, 8, 9. I know this bottom base is 9 units, so that's why it's on a grid, and I can count it over, and that's the same length. Base 1, I'm going to right now on the bottom, so that's 1, 2, 3, 4, 5 units, because I counted on top, and I know on this grid that's 5 units long. So now what this creates is it creates a parallelogram. Okay, so, and I know a parallelogram is area of base times the height. So if I think the area is going to be base times height for the parallelogram, but I know I don't want the whole area, I just want this simple area. And because these trapezoids are congruent, I'm only going to want half of my area. So this leads me to say, all right, the area of my trapezoid is going to be 1/2 my base times my height. And furthermore, this base is really so the base of a parallelogram is also really just the sum of my two bases added together. So that would be 1/2 base 1 plus base 2, and then multiply it by your height. Now this 1/2 will take into account that I'm only looking for half of the area. Okay, that's why I'm writing that here. The base 1 plus base 2, that's the base of your parallelogram, and then times your height. So the piece on the, without the 1/2, I'd be finding the entire area of the parallelogram. Add in the 1/2 multiplying factor, then you're going to find just the area of a trapezoid. So in short, the area is just going to be 1/2 times your height times the sum of your bases. Notice I just put the height in a different order because multiplication, the order does not matter. So there's the formula for one formula for the area of a trapezoid. Now, you can always take, and I always say, every shape can be described by triangles. So this is one reference to that. We're going to use a reference of something we know from triangles, which is called a midsegment. That means that M is going to be a midpoint, and N is also going to be a midpoint. And I know that if you look at just one individual triangle, for example, the triangle on the bottom left, the relationship between the base and that midsegment is that the midsegment was, yes, it was parallel, but it was also half of the size. So it's 1/2 of B. And if I look at the other triangle, that's going the midsegment there is going to be 1/2 of its base, which is 1/2 of A. Now, from this, I can find the area of just two of the triangles and add them together. Okay, so I can find area of the triangle that I highlighted in yellow. That's going to be we also need to know that there's going to be a height, right? And the height of both the triangles will end up being the same. So we'll have 1/2 the base times the height plus 1/2 of A times your height. Now, 1/2 of B and 1/2 of A, that's the length of the midsegments. So yes, you can just use this calculation, find the area of any quadrilateral, that works. But another relationship that comes from this is that you can factor out the H, and you'll be left with 1/2 B plus 1/2 A. Now, what does this piece represent? Well, that's going to be this, just the length of, here's your 1/2 B, here's your 1/2 A, and when you add those together, you get the length of the midsegment. So this is the length of your midsegment. So another way to find the area of your trapezoid is your height times your midsegment. Okay, so that's where we went from there. So you don't have to know both bases. If depending on the information you know, if you know the length of the midsegment, you multiply it times the height, then you'll get the area of the trapezoid. So this is just another diagram. It's not another way. It's just saying, hey, if I know my midsegment is 9 and my height is 3, then the area here is just 3 times 9. You don't have to know the bases. Okay, so you get 27 units squared. Now, getting into the kite. Okay, 2 cool ways to find the area of the kite. And I put this on the grid because I like to see you can actually count it and it's more visual. You can break this up into triangles. So a lot of people take this and they draw one diagonal and then draw another diagonal. And now we have kites. So one kite, or I'm sorry, not kite, one triangle, 2 triangles, 3 triangles, and 4 triangles. Find the area of the triangles, and you can just add up the areas of the triangles. Simple. Sometimes you don't have all the information, though. Another way to do this would be to think of it as a kite that is drawn inside a rectangle. And the diagonal from A to C is the same length as the side of your rectangle. So I'm going to call this, this is like, I'll say diagonal 1, because there's 2 diagonals in the kite. So this is diagonal 1. And the other diagonal would be horizontal. And this is my second diagonal. So diagonal 2. And this is the same length as the base of my rectangle, so this is also diagonal 2. So I can find the area of the rectangle here, diagonal 1 times diagonal 2. But what area do I really want to find? I just want to find the area of your kite. What you can see now with symmetry is that there's congruent triangles here. These 2 triangles are congruent. These 2 triangles are congruent. These 2 triangles are congruent. And also those 2 triangles. So really, you're only finding half of the area. So one way to find the area of a kite is going to be diagonal 1 times diagonal 2, and then you only want half of that. So it's 1/2 of the diagonal 1 times the diagonal 2. So you can always make a rectangle around it and say, all right, there's going to be congruent triangles. And this stems from the fact that we have perpendicular diagonals in a kite. Okay, so this is the main formula for the area of the kite. But know that Under certain circumstances, you can always use a triangle. And lastly, a rhombus. So a rhombus, rhombus is a parallelogram. So there's nothing new here then. A parallelogram is base times height. So in this case, this is a parallelogram. I have my base, I have my height, and you can just go base of 10 times 7, and there we get our area. I'm going to jump over to C. Now for C, because I have perpendicular diagonals, I also don't have a height. I got to look for some other information. There's symmetry in a rhombus and a kite, where this 6 can be mapped over, and then this length is also 6. And, what is this length? Well, from the Pythagorean theorem, we're going to be able to find this length, because a squared plus b squared equals c squared. And it's 3, 4, 5 triangles, so this measures 8. You can calculate it. And by symmetry, this is also going to be 8, we get 10, we get 10, we get 10. So like we talked in the last example of the kite, we can also use the same symmetrical relationship here by drawing a rectangle around it. That doesn't look drawn to scale. Back that up. Okay, let's take that a different route. So bottom line is you can look at this in triangles. Top triangle, I know would be 1/2. My base is 12 times my height 8, plus the other triangle, which is 1/2 base is 12 times 8. But look at, these are the same pieces. When I put them together, I only have half there and half here, so all together it's just going to be 12 times 8. Which if you look at that, 12 times 8, that's the same thing as saying 1/2 of the product of your diagonals, because the 8 is 1/2 times 16 is one diagonal, and then 12 is your other diagonal. So you can use the area formula for a kite on a rhombus, because once again it comes from having this perpendicular diagonal. And in B, this is an example where you kind of have to dig back into your bag of tricks. And let's not forget about right triangle trigonometry, or you can use law of sines if you want. So this is a parallelogram, base times height, but I don't know my height. Okay, but I do know these sides are all 10. So you can say the sine of 43 is equal to h over 10. So my height will be exactly equal to 10 times the sine of 43. So now I know my height. So the area is going to be the base, 10, times my height, 10 times the sine of 43. Okay, so just many different ways to find the area of a rhombus. You have to look for what you have and figure out what's needed, and know that there's multiple formulas you can utilize for the rhombus. That's all for now. I hope it helps. Please look forward to other videos that Ms. Schafran's putting online regarding the parallelogram and the triangles. I would recommend watching that one first. Have a great day.